Okay, so today we're going to do a quick PowerPoint presentation that will cover two subunits, and so this is your homework for the week. Parallel and perpendicular lines, and why is the sum of the angles of a triangle 180 degrees? So we start with an opening exercise. Jude and Jasmine leave school together to walk home. Then Jasmine cuts down a path from Schoolhouse Road to get to Oak Street, and Jude cuts down another path to get to Court Road. Below is a diagram of the route each follows home. What conjecture can you make about Oak Street and Court Road? Explain. So you'll notice in the diagram that, they kind of writing in interior angles, and then between Schoolhouse Road and Court Road, they're also writing congruent interior angles. So what do you think? They're all parallel. Let's just go back. Oak Street is parallel to Schoolhouse. Schoolhouse Road is parallel to Court Road. The implication is that they're all parallel to each other. And you would be correct. So this is a theorem. If two lines are parallel to the same line, then they are parallel to each other. You don't have to memorize like 3.8 or anything like that. If A is parallel to B and B is parallel to C, then A is parallel to C. You're going to prove that in the homework. But if you said, you know what, we can use that's true because of the transitive property or chain rule, you would be correct. Once again, it's going to be in the homework. The next theorem, it's a theorem that you have to prove, is that in a plane, if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. And we can see in the diagram, we have L and M are parallel, and we have this line N cutting through them. N is perpendicular to L. What is its relationship to M? And you would say, okay, well, N is also perpendicular to M. Well, in this class, we want to know why. And, take a second, pause, and then take a second to think about it. And so you would say, in mathematical proof, you say, because L is parallel to M, the corresponding angles are congruent. Therefore, because N and L are perpendicular, like that angle in here, right here, that would also be perpendicular because in parallel lines, corresponding angles are congruent. Therefore, N is perpendicular to M. You're going to be doing it in the homework. The next unit is proving triangles. The interior angles are 180 degrees. So draw and cut out a large triangle. What is the sum of the angle of the measure of the triangle? Explain. Do not use a protractor. And the idea, they say, tear off and rearrange the three corners of the triangle. So I did that. I drew a triangle. I numbered it. I cut it out. I cut the angles out, and then I lined them up, and it was a line. So you could say, okay, well, I guess the angles of a triangle are 180 degrees, but that's a conjecture, and that's not a mathematical proof. It's the beginning of it, right? And maybe Jocelyn did hers, and Liza did hers, and Zoran did his, but that's, once again, that's science. That's not math. So how are we going to prove this? Well, we need another postulate to prove this. And our new postulate is the parallel postulate, which states through a point not on a line. So we have line L, and then there's point P up there. There's only one line parallel that goes through P that's parallel to L. So this is the postulate. So I'm asking you, do you guys accept this? Zoran, do you accept it? Jocelyn, do you accept this? Eliza, do you accept this? And so once again, also please remember this only holds in a 2 space, all right, on a piece of paper. So now we're ready for the proof. And so if you see here, so the triangle angle sum theorem, the measures of the angles of a triangle is 180 degrees. So the first thing we're going to do is use the postulate to draw a unique line through B, which is parallel to segment AB. So you can see here, I had triangle ABC, and then I drew that line up there. And there's only one parallel line that goes through B, parallel to AC. And I drew in the numbers 1, 2, and 3. So my goal, And once again, the goal is to prove that A plus B plus C equals 180. Well, PR is parallel to AC. That's the parallel postulate. 2, I know that 1 plus 2 plus 3 equals 180 degrees because they make a straight angle. I know that angle 1 is congruent to A and angle 3 is congruent to C because alternate interior angles are congruent. And therefore, through substitution, A plus 2 plus C is 180 degrees, proving that the interior angles of a triangle equal 180 degrees. I wrote QED. You don't have to write that down. Okay. And once again, I'm using that word interior. Once again, is the angles inside. So let's move on to that idea of interior and exterior angles. Oh, and then there's some exercise. So, for example, you see at the top there's this triangle, and they give you the angle A is 59, and there's the B left is like 43, and B on the right is 49, and they're asking you to solve X, Y, and Z. As I said before, it just becomes algebra problems. So any suggestions? So you say, okay, X equals 180 minus the 43 plus the 59, which is 78. You know that Y is supplementary to X, so 180 minus 78 equals 102. And then the Z is also part of that triangle on the right, 49 plus 102. Take that from 180, you're left with 19. And so I'm asking you, did you notice the relationship between angle Y and the angles inside angle ABD? You might say, well, oh, you know what? They're the same, 102, 102. So let's take a look here. Let's talk about something called an exterior angle. So I'm going to draw a triangle. I'm going to label it ABC. And then what I'm going to do is extend one of the sides. I'm going to extend side AC and label it D. And now I've created two new angles, 1 and 2. One is the interior, but 2 is called an exterior angle to triangle ABC. Okay? And I'm interested in that angle. Angle 2 is supplementary to 1, but if you notice, there's also a relationship to A and B, which we're going to refer to as the remote interior angles. And so we're going to prove that angle BCD, or angle 2, is congruent to the sum of the remote interiors. Now, I'm not going to use a 2-column proof here, but simply put, we know the sum of the angles of a triangle is 180 degrees. We just proved that. So therefore, A plus B together are supplementary to 1. And since ACD is a straight line, 1 plus 2 is also 180. And they're supplements. Now, if you recall on the first day of proofs, we proved if two angles are supplements to the same angle, they are congruent. So angle BCD is congruent to angle A plus angle B. The exterior angle is equal to the sum of the remote interiors. As I said before, during class, we're going to prove these theorems, and then in the homework, you're going to see its applications. So let's look at some problems. This is from the book. We have a triangle, and it seems like that side is extended to create a remote exterior angle called 1. And we know that angle 1 is equal to 80 plus 18. Same thing with problem 2. 124 is a remote. I'm sorry, not remote. I apologize. Angle 1 is the exterior angle, and 80 and 19 are the remote interiors. In problem 2, we see that 124 is the exterior angle, and 59 and angle 2 are the remote interiors. We know that 59 plus angle 2 equals 124, angle 2 equals 65. So for homework, we're done. For homework, you're going to do Unit 3-4, which is PDF 207, and Unit 3-5, PDF 215. You're going to do all the odds and all the challenge problems. Excellent.